This is a demonstration of a PIC-based microcontroller project. This device here is a sun tracker where it will position the solar panel towards the sun for maximum output. This is the unit. Installed onto this black acrylic frame is a servo motor. It's a hobby servo motor. Attached to it is a solar panel with sensors mounted on the top. These sensors allow the microcontroller to detect the positioning of where maximum output is for the solar panel. But on the bottom of the black acrylic case here, there's a LCD. The LCD gives feedback to the user. It puts out the solar cell capacity, which at the moment indoors is only 0.4 volts, and the sensors 1 and 2, and also the mechanical movement position, which currently it is stopped. Up at the top of the LCD here, there's a on and off switch. Now in operation, the microcontroller will look at these, will actually read the sensors up on the top through a 10-bit ADC. The values are compared, and depending on where it is located with reference to a light source, one of the sensors will be in shade and the other will receive more signal. So therefore the microcontroller is able to determine which way to rotate the servo motor. The servo motor is controlled by 20 millisecond pulses, and depending on how wide these pulses are, the signal pulses, is where it's going to position the servo motor. The servo motor is driven by the interrupts, which, as previously mentioned, they're set at 20 milliseconds. Now what we'll do is, we can't take this outside because the sun tracking, although it will work, we can't do time-lapse photography to rotate the solar panel. So what we'll do is we can simulate a sun source with a torch. So what we'll do is turn the torch on. Here we go. And the microcontroller, as we rotate the source around, the microcontroller should be tracking the light. And this will maximize the output on the solar cell. So as I'm rotating this torch with my hand around, representing the sun movement, the solar panel is consistently facing the light source. This way it increases the output power to its maximum potential. So as I move this back, you can see that the device is tracking. Now if I hold the light in one position, like say for example here, it will maintain that position and hold it there so long as the light remains on. If I turn off the light like this, the unit will hunt down the maximum available light in this room, and obviously in this position it's wanting to face the curtains there. Mounted on the bottom here is a PIC16F88 controller. It's running at 20 megahertz. There's a linear low dropout regulator on the bottom, which allows it to be powered from batteries until the batteries are almost completely exhausted. There are two trim pots there that you see. The trim pots adjust their calibration values for the light dependent resistors. It's all it is, it's basically a voltage divider feeding into the analog port. Lots of white wires there, they're majority for the LCD connections. You can also see a sort of a slightly chunkier white wire which is coming from the solar cell, and that's also fed into the micro there for reading. Mounted on the sides are just two two sets of 2 AA batteries. So there we go. That's it for the sun tracker, or what would you, solar panel sun tracker.